Session 4.3, Graphs of the tangent and cotangent functions. For the session 4.1, 4.2, we know how to graph the sine and cosine. Now we need to know how to graph the tangent and the cotangent. Vertical asymptote is a vertical line that the graph approach but does not intercept. So keep in mind that when you have the vertical asymptote, the graph is only approaching to this line but never intersects. As the x values get closer and closer to the line, the function values increase or decrease without bound. Tangent function f of x equal to tangent x. I want you guys try to plug in x value into this function. Find out what is your f of x. The first one, when you plug in negative pi over 2 into here, tangent of negative pi over 2, you're going to get undefined. How about tangent negative pi over 4? You're going to get negative 1. Tangent 0, that will be equal to 0. Tangent pi over 4, that will be positive 1. And then pi over 2, that will be undefined. Okay, based on the table, I want you guys try to graph the y equal to tangent x. You should get this picture. When x equal to negative pi over 2, y will be equal to undefined. So this will be the vertical asymptote. You could see I used the dot line to represent it. Same idea for this guy. X equal to pi over 2, that will be the vertical asymptote. It means the graph is only approaching to this line, but does not intersect. Same idea with here. Okay, and then we only graph one period of the tangent x. Okay, this is talking about one period here. If I keep drawing the tangent x, you will have this picture. Okay, we do have a 1 period, 2 period, 3 period here. Okay, first, think about it. What is my period equal to? It's going to be from negative pi over 2 to positive pi over 2, right? So pi over 2 plus pi over 2, that will be equal to pi. Period equal to pi, and then domain. Domain is talking about the possible values of x. You can see x will be keep going like this way. So we're gonna say all the x, but cannot be equal to pi over 2 plus n pi. N is talking about the integer. For example, when n equal to 0, then x cannot be equal to pi over 2 because this is going to be the vertical asymptote. When n equal to 1, so I do have a pi over 2 plus pi, which is going to be 3 pi over 2. So x cannot be equal to 3 pi over 2 because this is a vertical asymptote again. Same idea when n is a negative 1, so I will have a negative pi over 2. X cannot be equal to this guy. When n equal to negative 2, that will be negative 3 pi over 2. So x will be anything, just not the vertical asymptote here. And then the range will be the possible values of y. You could see it's going to be keeping going down, and this is going to be going up. So range, that will be from negative infinity to positive infinity. Okay, x-intercept. So you can see x-intercept, that will be 0, 1 pi, negative pi, and this is going to be 2 pi, 3 pi, 4 pi. Okay, so x-intercept will be equal to n pi. Vertical asymptote. So that will be same idea just like the domain, right? But this time it's going to be equal to. So x equal to pi over 2 plus n pi. So all this red dot line will be the vertical asymptote. And then symmetry is going to be on the origin, right? So we say the graph is symmetric with respect to the origin. So the function is an arc function. For all x in the domain, tangent of negative x will be equal to negative tangent x. So this is the arc function. I need you guys know how to graph the tangent x without using the calculator. Okay, and also you need to remember all the vertical asymptote. Tangent x will be the direction is going to be increasing from the left to the right. Increasing from the left to the right. Okay, right? Now, we're going to graph the cotangent. Okay, f of x equal to cotangent x. Do the same thing, plug into your calculator. Your calculator, they don't have the cotangent x, so you may want to use 1 over tangent x. Okay, 1 over tangent x, that will be equal to cotangent x. Check the work. Okay, right? Based on the table, try to graph the cotangent x. You're gonna see this. Okay, a little bit different from the tangent x. Okay, this time that will be decreasing from the left to the right. And then we only graph one period of cotangent x. Okay, so if we keep repeating the cotangent x, it will be looks like this. Okay, the period is going to be equal to pi, right? From 0 to here, there's a pi. 1 pi, 2 pi, 1 pi here. Okay, so period equal to pi. The domain, same idea. Think about it. X cannot be equal to the asymptote. Okay, so that will be x cannot be equal to n pi. When n equal to 0, that will be this line. This is also the vertical asymptote. Okay, and then when n equal to 1, so x cannot be equal to 1 pi. When n equal to 2, so x cannot be equal to 2 pi. That will be the domain, all the x except when the x equal to the asymptote here. The range, possible values of y. So you can see it's going to be going up until positive infinity and then going down. That's a negative infinity. Okay, x-intercept. X-intercept, that will be from pi over 2 and then 3 pi over 2 and then 5 pi over 2, right? So you're going to say x equal to pi over 2 plus n pi. Okay, n will be the integer. Vertical asymptote, that will be the same idea with the domain. Okay, but this is just x equal to n pi. Okay, vertical asymptote. And then symmetry, same idea, that will be the origin. Okay, so this is also the arc function, because when you plug in cotangent of negative x, that will be equal to negative cotangent x. Pretty similar to the tangent x, but it just the graph is going to be decreasing from the left to the right. And then you could think about it, the graph is kind of shift to the pi over 2 to the right. Okay, the tangent function can be graphed directly with a graphing calculator using the tangent key. To graph the cotangent function, we must use one of the identities. So if you want to graph the cotangent, so use the 1 over tangent x, or you could do cosine over sine. Okay, guidelines for sketching graph of tangent and cotangent functions. Step 1, determine the period. period will be equal to pi over b. First, find out the pi over b. And then you want to find the two adjacent vertical asymptotes. Solve the following equation for the x. Okay, so this is the general form, y equal to a tangent bx. How you find your period? You're going to do pi over b. After you find out the period, you're going to find the two adjacent vertical asymptotes. You're going to set it up, the bx equal to negative pi over 2 and bx equal to pi over 2. Let's look at the graph again. Okay, this is the original y equal to tangent x. And remember that the two adjacent vertical asymptotes will be x equal to negative pi over 2 and x equal to pi over 2. And that's why first thing you're going to set it up, bx equal to negative pi over 2. And then bx equal to pi over 2. And then you're going to solve it. Then you're going to find out two adjacent vertical asymptotes. Same idea with the cotangent. Okay, cotangent, the graph is going to be look like this. So the two adjacent asymptotes will be x equal to 0 and x equal to pi. So that's why you're going to set bx equal to 0 and then bx equal to pi. Find out these two adjacent vertical asymptotes. Okay, sketch the two vertical asymptotes found in step 1. And then, step 3, divide the interval formed by the vertical asymptote into 4 equal parts. This is the same idea with the section 4.1 and 4.2. Okay, you find out these two vertical asymptotes already. Then, you want to divide it into 4 parts here. Okay, divide it into 4 parts. So 1, 2, 3, 4. And then you're going to use the half and half method to determine the x coordinate here. Okay, you evaluate the function for the first quarter point, midpoint, and the third quarter point using the x values found in the step 3. And then join the points with the smooth curve approaching the vertical asymptote, indicates additional asymptote and periods of the graph as necessary. So it depends on if the question requires you to graph 1 period or 2 period. Okay, example 1. Graph y equal to tangent 2x. First, find out the period. Period, that will be pi over b, right? So your b, that will be equal to 2. Okay, so period, that will be pi over 2. And then we want to find out the two adjacent vertical asymptotes. So we're going to set bx, which is going to be the 2x. 2x equal to negative pi over 2. And then 2x equal to pi over 2. Okay, 2x equal to the first vertical asymptote. And then 2x equal to the second vertical asymptote. And then we're going to solve for the x. So we're going to divide it by 2 for both sides, divided by 2 for both sides. You should get this. X equal to negative pi over 4 and x equal to pi over 4. So these two will be the vertical asymptote. And then we're going to sketch the two vertical asymptotes. The picture is going to be looks like this. And then one more point here. You can see when x equal to negative pi over 4, that will be this point. Y will be equal to negative 1. When x equal to pi over 4, y will be positive 1. So that's why we're going to put the 1 and negative 1 in here. And then step 3, you're going to divide the interval into 4 equal parts. Okay, these points, we got it from the two adjacent vertical asymptotes. Okay, negative pi over 4 and pi over 4. So write it down. And then we're going to use half and half method. Remember, add it up, divided by 2, that will be the midpoint here. So which is going to be equal to 0. And then negative pi over 4 plus 0 divided by 2. You're gonna get negative pi over 8. Same idea for this guy. Add it up, divided by 2. So you got pi over 8 here. Okay? This part, you're gonna calculate for the function. You're gonna plug in this x value, okay, to get out what is your y equal to. Okay, but I would just skip this step. I do have a 2 adjacent vertical asymptote, and then I have these 3 points. It should be good enough. Okay, this is gonna be your picture. Okay, now you do have these 5 points. You know these 2 lines will be the vertical asymptote. And then the negative pi over 8 and pi over 8, that will be the same idea with these 2 points. So it should be 1 and negative 1. 1 and negative 1. Okay, and then you know tangent curve is going to be increasing from the left to the right. Graph another period by adding 1/2 period to the left and 1/2 period to the right. Or you could just add up the 1 whole period here. Okay, example 2. I want you guys try find out the period, find out the 2 adjacent vertical asymptote, and then divide it into 4 parts, figure out the x values. Okay, check your work. Period equal to pi over b, right? And your b will be 1/2. So there's a pi over 1/2, which is going to be 2 pi. And then figure out 2 adjacent vertical asymptote. So we're going to let the bx equal to negative pi over 2. And then the bx equal to positive pi over 2. Solve for the x. So you're going to times 2 for both sides. So x equal to negative pi and x equal to pi. Now we're going to divide it into 4 equal parts here. And then use the half and half method. Add it up, divided by 2. And then add it up, divided by 2. Add it up, divided by 2. You're going to get all the x values. Okay, that's one more thing you guys need to pay attention. You could see that's a negative 3. Okay, instead of the 1, you're going to put the 3 here. And also, this is a negative, means they do have the refractions. When it's talking about the refraction for the tangent, instead of increasing from the left to the right, you're going to do decreasing from the left to the right. Okay, one more time. This is 3. That's just like the amplitude. So instead of using 1, you're going to put 3 and negative 3. And that's a negative. They do have the refraction. So instead of increasing, you're going to go decreasing. Okay, so you should have the picture like that. Okay, 3 and negative 3. And then it's going to be decreasing from the left to the right because of the negative. The function defined by y equal to negative 3 tangent 1/2 x has a graph that compares to the y equal to tangent x has follows. The period is larger. Okay, the period of this guy is larger because the b equal to 1/2 in here. But the b here is equal to 1. Okay, 1/2 is less than 1. So the period is going to be larger from here. The graph is stretched vertically because a equal to -3. Okay, the amplitude here, a equal to -3 here, and a is going to be equal to 1. And each branch of the graph falls from left to the right, the function decreases between each pair of adjacent asymptotes because a equal to -3 and -3 is less than 0. When the graph here is a negative, it's going to be reflected. Okay, that will be decreasing. And when a less than 0, the graph is reflected across the x-axis compared to the graph of y equal to absolute value of a tangent bx. Okay, example 3. I want you guys try. This is graph the cotangent. Okay, first find out the period. Period will be pi over b, right? So period will be pi over 2. Now we're gonna find the two adjacent vertical asymptotes. So you're gonna set bx equal to 0 and bx equal to pi. Okay, because the original y equal to cotangent x, the two adjacent vertical asymptotes will be x equal to 0 and x equal to pi. Solve for the x. Now we're gonna divide it into 4 equal parts. I want you guys try. Okay, added up divided by 2, add up divided by 2. You should get this. And then the amplitude a is gonna be equal to 1/2. Original is supposed to be equal to 1, right? And this is a positive, so that's a no refraction. So your graph should be looks like this. Okay, these 2 points will be represent 1/2 and -1/2 here. Okay, example 4. Graphing y equal to 2 plus tangent x. Think about it. What happens when you add an integer to a graph? Remember that we learned it from the algebra, y equal to c plus the f of x. When you're adding 2, so you're gonna move the tangent x 2 units upward, right? 2 units upward. So same thing here, it's supposed to be on 0, right? This graph, I'll let you guys look at here. It's supposed to be 0, right? Since you're adding 2, so you're gonna move these 2 points 1, 2 here. So becoming 2 here, becoming 2 here. And then the vertical asymptote doesn't change. Okay, example 5. Y equal to -2 minus cotangent x minus pi over 4. Okay, first, find out the period. The b will be equal to 1, right? So period is just equal to pi. And then just look at this guy here. Okay, forget about the -2. We have a y equal to negative cotangent x minus pi over 4. Because of the negative, we know that it's going to be refraction. Okay, it's supposed to be decreasing function because is a negative, it becomes increasing function, increasing from the left to the right. Also, we do have an x minus pi over 4. Remember that x minus pi over 4, that means we're gonna shift pi over 4 units to the right. Okay, pi over 4 units to the right. After that, we do have a negative 2. So you're gonna shift the whole graph 2 units downward. 2 units downward. Okay, now we're gonna figure out the adjacent vertical asymptote. Okay, we're gonna set this guy equal to 0 and set this guy equal to pi. Solve for the x. You're gonna get x equal to pi over 4 and x equal to 5 pi over 4. Okay, just like the previous example, you could consider this as the whole thing, the bx equal to 0, bx equal to pi. Now, we're gonna divide it into 4 equal parts. Try, add it up, divided by 2. Okay, you're gonna get 3 pi over 4. And then add it up, divided by 2. And this 2, x pi over 4 divided by 2, which is gonna be pi. Okay, right? So we're gonna combine everything together. Gonna be shifting to the right, pi over 4 units, and then shift downward 2 units. Okay, example 6, determine an equation of graph. So this time I give you guys the picture here, and I want you guys figure out what is this graph. So first, vertical asymptote. We do have a 2 vertical asymptote. So you have x equal to negative pi over 2 and x equal to pi over 2. Refraction. For this one, you could think about it when you have the asymptote is negative pi over 2 and pi over 2. I could think about the graph is y equal to tangent x. However, the graph is going to be decreasing from the left to the right, right? The tangent x is supposed to be increasing from the left to the right. Okay, so we could think about it. We do have the refraction here. So I could guess the graph is going to be y equal to negative tangent x. And then this is going to be negative pi over 4. It's supposed to be 1 here, but now we do have the 2. So I believe that the amplitude will be negative 2, right? Okay, so looks good. So I should have a y equal to negative 2 tangent x. Okay, B. How about this one? Can you guys try? Write it down. What is your vertical asymptote? Do they have the refraction? It should be y equal to tangent x or y equal to cotangent x. Do they shift upward, downward, or to the left or to the right? Think about it. Okay, vertical asymptote, x equal to 0 and x equal to pi over 2. So I would consider that would be the y equal to cotangent x, right? But then the period will be pi over 2. Okay, period will be pi over 2. Remember how to find the period? That's a pi over b, right? So I could say pi over b equal to pi over 2 here. And then b will be equal to 2. Okay, so I would say y equal to cotangent 2x, right? Because we figure out what is the b here. Do they have the refraction? No, right? Cotangent is decreasing from the left to the right. Okay, and then for the midpoint here, it's supposed to be pi over 4 and 0, right? But right now it become pi over 4 and negative 1. So we could believe that the graph is going to be shift down 1 unit. Okay, so that would be negative 1 plus cotangent 2x. Okay. Because the circular functions are periodic and there are infinitely many equations that corresponds to each graph in example 6, confirm that both the example 6b, this is gonna be our answer, y equal to negative 1 plus cotangent 2x. Actually, we could use it as a tangent graph. Okay, we can do like the refraction, so become negative, and then we could shift the tangent graph to the right pi over 2. Okay, so both of the answers are correct. When writing the equation from a graph, it is practical to write the simplest form. Therefore, we choose values of b, where b greater than 0, and write the function without a phase shift when possible. Okay, that would be too much if we use like the shifting to the left or to the right. That's it.